All right, there's some of the semester left, but I thought this would be the best discussion to have on a video, or at least initiate through a video, since we can't actually have a discussion while I'm speaking to you by video. I thought we would have a discussion of the last item on your syllabus, the economics of renewable energy, especially as applied to generating electricity. And I was very lucky when I put this in the syllabus. When I searched the internet to go above and beyond what's in your book, I found a very good source. It's a very good source because the authors and I disagree in some areas, not so much in economics, but the interpretation of the natural science data that ultimately informs us economists. And anyway, so I thought this issue would be the best one to bring to you by video. By video, I think it's important to have something that people can readily relate to, not so much managing forests and managing fisheries, not so much that, but we can all relate to electricity, and we've seen electricity bills, and a lot of us have lived in different places, and we know electricity has different costs in different places, and how big an electricity bill can be. We can all relate to that, and we know that there are a lot of different ways to make electricity, and you may or may not know that the cost of those differs a lot, especially at the margin. In other words, some of the ways used to make electricity are in the mix, despite the fact that they're not very competitive at current price levels. Now that may be because some people demand the right to feel better about themselves, to spend more on electricity generated, for example, by solar energy than they could if they didn't elect to do that. I mean, you can do that in some places. I think you can do it here in San Antonio, although I couldn't say for sure because I've not ever looked into it. But you can decide to pay more for electricity by electing to support the generating of it by windmills or by solar farms and so on. And then that makes you feel better because you're not contributing to global warming, and so that to some people is worth the additional cost. So anyway, since a lot of you can relate to this issue, I thought I would bring this to you by video, and then we also, if I waited till the end of the semester to do this like on the last day of class, we wouldn't have a chance to discuss it, and that wouldn't be good either. So we're going to use class time to discuss forests and fisheries and water management. It's just kind of a borderline issue. Yeah, you can probably relate to that almost as well as electricity, but maybe not quite as well. Water bills don't tend to be as high as electrical bills. We take it more for granted that water is going to be available. Electricity, you actually have to produce it. Water, you just have to move it around. And so we'll do those others in class, and we'll discuss this definitely and absolutely as you react to some of the things. Write them down and get online and post something while it's fresh on your mind, and before we get a chance to talk about it, I can see it there, and I'll be more ready to discuss it with you. All right, so Timmons, Harris, and Roach have at Tufts University, economists, have done a good job of explaining something very carefully. That's the other reason that I like this. We disagree, so you're going to see both sides of an issue. Don't agree on everything, but sort of in shades of green. We disagree on some things and how some things should be characterized and what perspective one should take on some things. But they're good economists in that they put their assumptions out there so that you can know exactly what they're coming from. Hidden assumptions are not good things, so they're not guilty of that. They're right out there in front, and that's part of what I disagree with is some of their assumptions. Not necessarily that they're wrong, but they're a little shaky. We're not sure enough whether to ground a multi-billion-dollar policy on these shaky assumptions. And the big one we've talked about already is the climate change issue. That's the bottom line, and their assertion, after careful analysis, that we need to undergo a rapid transition from fossil fuel-based, some nuclear, but that's been pretty steady, a fossil fuel-based dependence for generating electricity to one that's gradually gets rid of the fossil fuel dependence and relies on sustainable, renewable energy, wind, solar, geothermal, that sort of thing, things that are not depletable, like the fossil fuels, those are non-renewable things. Every time we burn one up, there's less of it available than before. Now, that said, they're also pretty abundant, and we probably just scratched the surface on the amount that's physically available in the earth for fossil fuels. But nevertheless, it's accurate to say that it is a non-renewable resource. Okay, so Timmons, Harris, and Roach, and I think for now I'm just going to call them THR, Timmons, Harris, and Roach from Tufts, say that we're in an energy transition. The only question is how fast, and because of global warming, we need to do what we can through the political arena to accelerate it, because just given the prices of actually producing it from the earth, the renewable energy is not going to be competitive with fossil fuel energy anytime soon. Only if we fully, by their measure, fully internalize the costs of burning fossil fuels. And the biggie in terms of that internalization isn't the ground level air pollution that's directly addressed by the Clean Air Act, but the big kahuna is the catastrophic climate change that they and many others foresee. I shouldn't say that they foresee it, but they believe the natural scientists that argue that it is going to be catastrophic. Some say agree with that, some don't, as you know from our earlier discussion. So, is it natural to have this accelerated transition in the sense that it's natural or normal or desirable to internalize these externalities? Sorry for the jargon, but to make people pay for these third-party effects of rising sea levels and more frequent storms and higher heat in the summertime and all those negative things that they think that we can avoid through this transition to change in atmospheric chemistry that'll keep our planet a little cooler if we follow through. Or is it forced? You know, is it a matter of maybe we overestimated the cost of some of these things? I remember our methods from earlier in the semester where we talked about how one estimates damages or damage avoidance. Things like hedonic methods, survey methods for recreational sites, travel cost methods. These methods are, to a great extent, an art form. Okay, so the numbers that come out of them are not exactly solid numbers like those that come out of observable markets with observable prices, but nevertheless they're real, or they could be, and so we need to include them, at least as I noted earlier in the semester, as a residual, saying, well, it's hard to get a number for these, but it's something we need to consider, at least as a residual of this project is feasible, this policy is feasible if something is worth this much, and then we can argue that it is or it's not. All right, so the transition that THR argues should be accelerated is motivated by many factors: environmental impact, especially climate change, limits on fossil fuel supply. See, that's one area where I disagree with them. Sure, it's physically limited, it's non-renewable, but the limit is economic. Okay, the cost of getting these fuel supplies out of the ground, the cost of moving them around, the cost of combusting them to use them to convert energy, the cost of disposing of the wastes that result or processing the wastes that result. That's the real limit on fossil fuels, not the fact that there's only a finite amount of it in the earth. And then, of course, the other big issue is how much smarter are we going to get in the near future in terms of our ability to process these things in less harmful ways. And so maybe the fossil fuels, we'll have some invention like with fracking on the front end of getting it out of the ground cheaper. Maybe we'll have some incredible invention at the back end where we can more safely burn it. Who knows? That's what makes one of the things that makes this interesting is that we don't know what some of those are. So be cautious, but not too cautious. Exactly what does that mean? We all will differ exactly in what it means. All right, so the ultimate finiteness of fossil fuels is probably not as important as scarcity measured by price, which may or may not need to include internalization of these otherwise unpriced effects like climate change. And again, to give THR credit, the reading, the thing that I posted on your learning module and on your syllabus, it eventually does focus on economic scarcity as opposed to the notion that it's finite in quantity. Okay, so prices also are hard to get a firm handle on in this case because they already are distorted by intervention. So here we're talking about a further intervention, for better or for worse, in a market where price differences are the result already of intervention. Depletion allowances, other tax treatments of fossil fuels, liability limits on nuclear power, all kinds of subsidies for different kinds of semi-renewable, renewable energy. I'm not sure there's any way to know exactly what the price would be if you got rid of all of those subsidies. And I'm not sure how interesting a question that is, because the probability, given the nature of the political process and how important inertia is, the probability of getting rid of all the subsidies and going back just a clean system, and then seeing what we need to do to dirty it up again with intervention because of these externalities, it's not going to happen. Maybe we can muster the political will to harmonize the subsidies, to say, okay, it's not going to happen to go to no subsidies. But maybe we can put them all back in a playing field by harmonizing. I'm not so sure. As a political pundit, that's even much more likely than eliminating the subsidies. Both are a reach. Okay, so I keep bouncing around among these pieces of my script. Again, there'll be something online there. I'm recording this several weeks before I've finished all my other pieces of that learning module. So I'm going to put something there eventually, probably this script, so that you can look at it alongside with this video, and you don't have to write frantically to keep up with me. So I have to consult it every now and then to decide what I've already covered ahead of when I meant to, and what I still need to cover. All right, so are we fostering a transition or forcing it? And certainly some of the latter, because of that belief in the externalities by some, but not by others. Are we overdoing it? Have we overestimated the cost of this? And the big issue there goes back to our earlier discussion of climate change, and that is, to what extent are all the sources going to be in on all of this? If we internalize the externality, the part that we're responsible for, our contribution or possible contribution to the change in atmospheric chemistry and the effect of that, but others don't, how does that factor into whether we should do any of this to level the playing field between fossil fuels, which are causing these externalities, and the renewables, which frankly sometimes have their own set of externalities, but at least not the kind that lead to air pollution and possibly to climate change. Well, what I mean by some of their own externality, well, we know that windmills kill birds, and they're ugly. A lot of people don't like to have to look at them. They're land intensive, right? So we've got an opportunity to cost there in terms of using the land. If one of the nice partners in terms of generating electricity from wind is to have a place where you can put water to store it uphill of a generator, right? So if you have windmills spinning along, and sometimes maybe the demand for energy is low, what do? You use the energy to pump water uphill into a reservoir. So you've got to have some place that you can fill full of water, right? So that later, when there's more demand than the spinning wheels of the generator are creating, well, you can let some of that water flow back downhill and recapture 75% of the energy that it took to pump it up the hill in the first place, which is, by the way, is an enormous benefit to be able to take wind energy from when it's windy in the middle of the night, when energy demand is low, and be able to get 75% of that back in the middle of a hot summer afternoon when everybody's got the air conditioner turned on. That's huge. So what's the externality involved there? Well, you've got to find a piece of land that you no longer desire to have exposed to sunlight, to inundate it with water, and it can't be managed to be a nice lake that people can recreate on. It's got to be able to fluctuate a lot, because you're going to fill it up when it's windy, but the energy demand is low, and then you're going to drain it or partially drain it whenever the energy demand is high, but it's not as windy. So it's not a nice lake that you can use. At times it'll be empty, and other times it'll be bank full. So you've got to give up some land, and maybe the fluctuating lake doesn't look all that ugly. Maybe it's on top of an ugly piece of property. It's not that big of a deal, but there's going to be some trade-offs in that regard. Where would the water have otherwise gone? What would otherwise have been used to? Maybe it would have otherwise flowed downhill into a coastal marsh estuary, which is rich in environmental benefits, and dry up, or at least partially dry up that estuary and have some environmental and some, more environmental trade-offs involved. It's a complicated world out there. We can't be sure that fossil fuels are more subsidized now than renewables already are. So maybe maybe we've already at least somewhat internalized some of the climate change, again, depending on your view of how serious and how urgent the imminent climate change is. The system of subsidies we've already stumbled into may have already unleveled the playing field from just the natural production costs by enough to do that. The basic point there is the estimation methods are anything but absolutely objective, and the ability to disagree on what to do and how much to charge as a emissions fee or a Pagovian tax, as it's more generically called, the ability to disagree is rather massive. Another issue that arises in this notion of we're in a transition. This is the question of how fast it's going to be. Doggone it, they invented fracking. That's going to slow down the transition. We need to accelerate it again. At least, some people feel that way. So it's made it harder to switch to the renewables that we need to do. Another issue that's in that is the treatment of nuclear. Okay, to what extent is it subsidized by limiting the liability of nuclear power plants for when there's a big accident? To what extent is regulation that's over the top and overkill made it unrealistically uncompetitive? What about likely improvements in technology that would allow us to do something that would loosely be called nuclear, for example, through thorium rather than uranium? That's about all I know about it. It's less likely to have nasty accidents. But what if we invent a technology or better developed ones that seem to already exist that would allow nuclear to shed a lot of its baggage that it already has? How would that factor into this transition? Maybe the transition would be from carbon-based fossil fuels to nuclear, not to the wind, solar. Ultimately, the photovoltaic cell stuff, I think there's enough acreage and enough sites, especially if you count water ultimately as a place to put some of these things, that's the ultimate MEC sub. You may remember that term from a recent lecture. I'm not sure exactly where we're going to cover that as I record this video, so maybe that'll come up. But the MEC sub just means that the ultimate limit on how high the price of achieving some objective like generating electricity can go, that would definitely be the photovoltaic. It seems to be a source of very large quantities of energy, but at a very, very high price. And so if it costs more than photovoltaic, forget about it. But possibly through internalizing of externalities, we may be able to make competing sources no cheaper than photovoltaic, and then, by golly, absolutely do the photovoltaic, because it's unlimited, it's renewable, and it doesn't have any nasty direct properties. Now, if we were to look into the process of building those solar farms and the solar cells, we might discover that there's some pollution, some residuals involved in it still. Doggone it, there's nothing out there that's totally pure, but probably the nature of those residuals is more benign than the residuals that result from burning fossil fuels and constructing furnaces and that sort of thing. As I've mentioned once before in class already, the issue of nuclear power to a great extent is a non-marginal sort of an issue. By that means that some of the things that are most objectionable to some people about nuclear power are things we have to do no matter what our stance is about generating more electricity from nuclear power. That stems from military uses of nuclear power, as well as past uses of it to generate electricity. We've accumulated some waste. The volume of it isn't gargantuan. So it's not a matter of we've got to find a bunch more Yucca Mountains, or that's a place that's widely considered a good candidate for safely storing nuclear waste for a long time, Yucca Mountain. We don't need to find a bunch more places if we were to accelerate the use of nuclear power for energy. So there's a lot of assumptions out there that critically affect whether the transition that we're going to do is going to be fast or slow, and whether it's going to skip nuclear and go straight to wind, solar, totally renewable, seemingly emissionless, pollutionless sources. Still, there's some. I think, for example, in West Texas, think about those wind farms that we have out there. There's a lot of driving involved for people to go out and build and maintain those things. They're a long way from anything. So, those emissions are part of that deal. Whereas, of course, the turbines themselves don't create any emissions. But maintaining them and building them and such, absolutely some emissions. Okay, so I'm going to stop here for a minute, just to not have you have to pause and endure too much at one time. And then I'll pick it up in a few minutes, and you may pick it up in hours or days. All right, I'm back, and so are you, although for you it might be days later. For me, it's only minutes. A little bit of a water break, looking over my script, seeing what I've already covered, a little ahead of myself again, what I still need to talk about. Had some additional thoughts. It's amazing. One of the things that I've assumed all along, or touched upon, but maybe not got into enough depth, is the notion of, darn it, why are these these renewable energy sources, wind and solar and others, why are they so darn expensive? The fuel is free. Why can't they compete with something that you got to put in a giant burner and haul thousands of miles from a mine somewhere to create heat, and at a relatively low efficiency at that? I think the bottom line reason, other than, there's some land intensity issue there. It takes a lot of land for a lot of these, and the sites are limited and competing for other things. But I think perhaps the biggest factor is that we haven't figured out very well how to store electricity yet. I'll tell you that the issue of battery technology must be an unbelievably hard nut to crack, because given the value of the ability to store electricity from times when Mother Nature is creating it like crazy to times when it's demanded like crazy and Mother Nature isn't providing any of it, like, for example, when the sun's shining or the wind's blowing, but the energy demand isn't all that high. Inventing new technology must be tough, because I bet there's a lot of people on it, because it would be worth a fortune to do it. As far as I know, the best way we have now are these pump storage reservoirs that we have, these temporary lakes that we have. By temporary, I mean in terms of days or hours. Sometimes they fill, they empty, they fill, they empty. I mean, during a day even, it's, it could be windy, and so we're generating electricity like crazy, but there's no direct use for it, so we're pumping water uphill, and then later on, lots of demand and not so much wind, and so now we have this water uphill, and we can run it downstairs and sort of even out the availability of electricity with the actual demand for it. So in the absence of that sort of an arrangement, the pump storage arrangement, the only way we can meet right then and there, which is the sad thing about electricity, that's what we have to do. We can't meet it a little bit later or ahead of time. It has to be right there, and then, when the demand is there, that's when the electricity's got to be supplied. So in the absence of some sort of a pump storage arrangement, which is costly because of the land requirement and the topography you need to have part of your facility at a much lower elevation than the other part for generating electricity, is you've got to have some fossil fuel. Probably it's not easy to start up and power down a nuclear facility. You've got to have some sort of a fossil fuel driven, easy to start up, quick to shut down. And I didn't say cheap, because that's the problem with some of these turbines that operate briefly and then shut down, is they're called peaking units that exist even in the absence of any renewable energy use because the demand for electricity is up and down, and we have base load electricity, and then for the demand that's up and down, we have these called peaking units. Well, we need peaking units with renewable energy generation to be leveling units as opposed to peaking units, and I suppose also peaking units at the same time. Because if the demand is steady but the wind isn't, what are you going to do? Well, you've got to meet the demand with something. When the switch turns, the light's got to go on. So you've got to crank up or down some other source as the sun doesn't shine so much on your voltaic cells, or the wind doesn't blow through so much your windmills. Now, one thing that's possible in some places that's a good idea, depending on how you manage your reservoir, is integrating wind turbines with an existing mega reservoir. Lake Mead, Lake Powell, they're not so mega anymore. The water level's way down because it's been dry. Flaming Gorge Reservoir is another one, and that's one in particular I know that maybe now, and at least at one time, there was integration of the windmills that in windy Wyoming, that's where Flaming Gorge is Utah, Wyoming. There's integration of that water going through the turbines of that reservoir with how windy it is. So, that's a leveling thing. But there's only so much water in Flaming Gorge, and there's no provision that I know of to pump it back uphill after it goes through the turbines to let it go through again later. So there's only so much of that possible consistent with the other uses of that water for downstream recreation and irrigation and so on, and sort of wanting to maintain the lake at a sort of, not absolutely level, but somewhat level deal for recreational uses. So that's the big reason that renewable energy is expensive. It needs a partner. It needs another source to be able to be up quickly when the source of the renewable energy is down quickly. Now, as THR pointed out quite accurately, and I learned something from this, if we really, really are good economists, we can really, really, really rely on the price system to offset at least some of the ups and downs, depending on the price elasticity of demand and depending on the sort of the biofeedback process that you have. We can use the price system to make demand match the ups and downs in supply a little better. I don't know if you can do it enough to not have these units have to sit around and wait to turn on and off suddenly if necessary. Maybe some progress in that direction is still worth a lot. But for example, they point out that you can have utility meters that charge different prices at different times. Charge less when it's windy, for example. Charge more when it's not windy. Okay, so supply or scarcity driven as well as demand driven, and that would vary during the day. Now, the issue there is, well, how's the consumer supposed to know that if they flick the switch on their dishwasher right now, it's going to cost them a lot more to do their dishes than an hour from now because, well, it just happens to be not so windy right now, and an hour from now it will be windier. Well, that's where that sort of a biofeedback mechanism needs to come in. You either need to have appliances that can somehow be told when the price is low, and then they click on. For example, you could tell your dishwasher, if it's properly configured information-wise, okay, get the dinner dishes in there. Somewhere between now and breakfast, turn on when the price bottoms, whatever that means. And then that's when the dishes. So somehow if it's a smart dishwasher, it'll know, okay, that's as low as the price is going to go now. Click on, okay, and then it runs, and then, and the dishes are still clean the next time you need them to be clean. Sure, and of course all those things have costs too to make dishwashers and electric meters smarter and all that, but ultimately those kinds of things seem like they wouldn't be terribly costly. So anyway, so that we can make the demand fluctuate more than it already does, and make it fluctuate more in concert with the fluctuations in renewable energy. Can we do it enough to eliminate the need for some of these offsetting facilities, or at least the need to run them as much? and enough to make a difference in the cost, I'm not so sure. But anyway, it's something worth exploring and thinking about, because the price system is an awesome thing. And, just speaking as a consumer rather than an economist, I don't care when I run my dishwasher or clothes dryer, a lot of appliances. And I already, being an environmentalist and one interested in my pocketbook as a taxpayer as well as a consumer, I already don't do things like running my dishwasher in August in San Antonio in mid-afternoon when the demand for power is peaking because of air conditioning. Something that's got to be had right there and then. I don't need my dishwasher or my clothes washer or dryer. I don't need them to process what's in them at the heat of the day in the summertime or the cold of night in the wintertime, somewhere else where that's the driver of demand for electricity. I get a warm fuzzy. I'm holding my heart in case you can't see that on the screen. I get a warm fuzzy from knowing that I didn't push the electrical system as hard as I otherwise would. And not to make overly light of it, that can work, in a population of a large enough people. Divvying out or dishing out the warm fuzzies can put a dent in the demand for electricity. And definitely we should at least provide for meters that provide for time of day pricing of electricity, and maybe that'll make the demand for electricity more price elastic, just by the fact that people know when it's more expensive and when it's less expensive. All right, so wow, it would be cool if somebody could invent some better batteries, and I know from the price incentive that they must be trying, and someday they'll succeed, and that'll be huge, and that'll probably be bigger than anything in terms of being able to phase down reliance on fossil fuels and phasing up things that are cheap in terms of delivering power, but not necessarily when you need it or want it, but just delivering it sort of randomly when it's sunny or windy. And lots of power can be delivered suddenly, and a lot of it is just lost because the demand isn't there. But if we had good battery technology, it wouldn't be lost. Another issue that the THR bring up needs to be considered is an increased reliance on renewable energy is going to probably radically change where the electricity comes from. That would mean a pretty massive rewiring of the grid. So that's a cost above and beyond the fact that these sources have different marginal costs for actually generating the electricity in the first place. We might need to send it from different places and send it further. Okay, so another issue would be the technology of moving electricity around. You may not know that a lot of electricity is lost in the transmission, the moving it from place to place. There's just resistance losses, and maybe the renewables can be generated closer to the source of the demand than the fossil fuel driven or nuclear driven things. I'm not sure. I haven't read anything saying that one way or the other, but it also may be the reverse in any event. Where we get the electricity from and where is probably going to be different, and that'll entail some investment in a different power grid. Now, one way we might be able to just totally set all of that aside is to say, look, we've got to tax something to pay for soldiers, cops, firemen, the things that the government's going to do, no matter how much you believe in limited government, and got to find the revenue from somewhere. Well, that being the case, then we can just say, look, we don't need to worry so much about trying to measure through all these fancy methods that us environmental economists teach about inferential techniques and hedonic methods and, travel cost, all that stuff we've talked about. We don't need to worry so much about that. Let's just decide how much money we want to generate from something that we want people to stop doing. In other words, we want to generate the money from something that we want people to avoid the tax. Not evade. That's illegal. Avoid the tax by not doing what's being taxed. How much of our money for paying for basic government functions do we want to generate from a tax fee on that basis? And once we decide that, then do that at least, sort of a no regrets approach, and then give that a few years to run and see where the emissions are and see how the economy's adjusted to that different price for either fossil energy or nuclear energy or energy in general. If it's just energy in general, then it wouldn't help the transition as much. It would just improve efficiency and some of these smart meter things and smart appliance things just by making it more expensive. If we put the tax or the fee on the carbon content of energy as sort of a carbon tax, yeah, then we better decide how much of our revenue for defense and justice and parks and everything that the feds and the states and the locals, depending on who's going to get this revenue, how much of that revenue we want to generate from something we want people to stop doing. Because if we succeed, and people figure out how to do that cheaply and stop, and then they're not paying the tax anymore, then we have to be ready politically to find some other source of revenue to finance those things. Frankly, I recommend that. By recommend that, I don't know exactly how much we should rely on that, but some. And I think I mentioned in class in late October, just a few days before I'm recording this, but probably a month or so before you're going to look at it, that Washington State has just such an initiative on their ballot here in the next, actually, probably by the time you see this, it'll have been voted on already. I think it's on the November 2016 election ballot that says, let's put a tax on carbon, but let's not give the state government any more money to spend. We'll offset that by lower business taxes and some other reductions. I'm all for it. Although Washington State may discover that to finance their operations in that manner may be difficult to sustain long term. They may be victims of their own success. We know from other experiences that when you put a price incentive on something, people do figure out a way to lower the price, or if the price is set by the government, to lower the quantity that they do at that price. But I think I'll take that chance. If I were king for a day or governor for a day at Washington State, say let's pass that initiative and see what happens. And then if we're not happy with how far that takes us in terms of the environmental benefit, then we can do something else at the time. All right. One of the other things that I want to talk about is the issue of invisible versus visible. The Obama administration, when they had the Congress on their side in the early part of the administration, 2009, 2010, they tried to muster the political will to enact a tax on carbon. Couldn't do it. They had enough Democrats to achieve it without any Republican votes. But now just the idea that it would visibly increase taxes. See, it wasn't going to be just revenue neutral. It was going to increase the government's tax take, the federal government. So that gave enough of the Democrats pause that they couldn't muster the votes to pass it. So what are we doing now? And we'll see probably before you see this video, we'll see whether that's going to be sustained politically. The Obama administration relied on regulation to the Supreme Court allowed the use of the Clean Air Act to be used to regulate emissions that were only relevant because of greenhouse gas potential things, to basically add a criteria pollutant to the Clean Air Act, namely carbon dioxide. And so the idea there is it can be politically feasible to do that when it's, tell me lies. Don't tell me it costs anything. Just do it. Hide the cost someplace. Don't make the cost explicit in the form of a fee or a tax that I can see. Just get it done, and yeah, it'll be costly, but I want to pretend it's not costly, and I want things to be hidden in prices that are going to go up, but not for obvious ways, like it's going to be obvious if you put a tax on something. The price of the things that tax affects, like if you put a tax on carbon, yeah, electricity is going to be more expensive for sure, and certainly carbon-related fossil fuel generated electricity is going to be more expensive. But it's going to be more expensive too if you regulate the use of carbon-based fuels. It's just less obvious. So it's sad that the politics of it is what it is. because it's a lot more efficient to do it through a price system, an explicit price system, to make it more costly in an obvious way than to do it in a hidden way. But we keep doing this. You know, is the same notion for dealing with the non-attainment in cities for air pollution is, yeah, reformulate gasoline and do a bunch of things, and they'll be costly, but it won't be obvious that it's costly to the typical voter, so they're not going to be as mad at their representatives for having done it than if they make it obvious that clean air has become more scarce and that doing something about it is going to cost money. All right, so I'm just kind of finishing up this discussion. Should we get rid of all subsidies and then have some Pigovian taxes, some internalization of externalities through fees? Would that be the ideal thing? Maybe eventually. Again, from an efficiency perspective. I'm not telling you how to think, but I know efficiency is something that if it came down to it, it could be mathematically provable, and intelligent people still disagree when faced with these proofs because there are other things that matter other than efficiency. But ultimately, I think probably, at least initially, probably not. Fossil fuels are well-developed technologies, and maybe we still want to subsidize some elements of that because we keep finding more of them, and fracking and all that keeps making it cheaper to take it out of the ground. So maybe we want to still subsidize some basic research into mining and some basic research into processing the emissions into more benign forms. But I think for sure on the renewables, we still want to spend some money on subsidies, not subsidies to buy the stuff. I think we want to get rid of all of that. And maybe not immediately, but eventually. But still some subsidies on the research, basic research on capturing the renewables, battery technology. I think we definitely want to push as hard as we can there. That would yield a huge social benefit to figure out how to store the energy that arrives when we don't need it, to have most of it left over when we do need it, by methods other than pumping water uphill. That would be big. I think we still want to subsidize that. So can we harmonize subsidies, and is that worth trying to do? I'm not so sure it is, given that the notion of harmonization is hard to prove and might just be battle royale over between some pretty powerful people and dissipating a lot of political energy over something that might ultimately not matter so much. Okay, so to sort of summarize this, the key here is not that fossil fuel is a non-renewable thing. We can, strangely, and you may have heard this before you see this video, depending on exactly what else we've covered in class, but we've never run out of a non-renewable resource, and we have run out of renewable resources. Of course, not solar and wind. We're not going to run out of those. But the issue with so-called non-renewable resources is economic depletion, not physical depletion. So we're going to make that transition to some kind of a substitute, nuclear or photovoltaic or wind or something like that, long before we physically run out of oil and gas and coal. And so the issue before us is, above and beyond how much we want to rely on a different source for our meat and potato government expenses, above and beyond that, how much should we raise the price of fossil fuel energy to take account of externalities that we disagree about to a great extent? How much global warming is there? How bad is it versus some places it's going to be good? To what extent do we value the losses to losers more than the gains to gain? I mean, with global warming, it's not going to be so cold at night in Canada, and that's definitely worth something, for growing seasons, not to mention just comfort and heating bills. Yeah, that's, global warming, to the extent that it happens, is hypothesized to not exclusively occur in winter at night at higher latitudes, but disproportionately at least. That's definitely a benefit. Yeah, sure, if it happens and the sea levels rise it'll flood some places that, that seawalls might not be adequate to replace enough to protect, especially under stormy circumstances. We might want to still have subsidies, especially for basic research kind of things, and not so much for the actual consumption or mining of them, and definitely for the further development of things like fossil fuels. Not fossil fuels, but renewable fuels, and the ability to store the energy either by pumping water uphill to some places maybe that we haven't thought of before, make landfills into hills, where we can somehow store water on the top of them in places where there isn't a whole lot of topography to work with. Lots of ideas to process, and maybe some of those need to be subsidized. But ultimately, it'll be an issue of how big we think the threat is, mostly the threat of climate change, and what numbers we can place on the value of diminishing that threat, and compare that to how important we think it should be to have an economy with a higher level of energy intensity. So I look over my script quickly at your expense of continuing to have this video on. I think that pretty much covers everything. We're definitely going to have a transition to different ways of generating electricity, but it might not be fast, and maybe it shouldn't be. We'll see you soon.